Imagine a time when the very concept of science was still in its infancy, when the mysteries of the universe were unexplored and the forces that governed nature were unknown. Amidst this intellectual darkness, one brilliant mind emerged, forever changing the way we understand the world. A man whose ideas still shape the sciences today, whose inventions continue to impact modern engineering, and whose mathematical genius paved the way for discoveries we now take for granted. This is the story of Archimedes, a man whose curiosity, creativity, and intellect revolutionized science in ways that continue to resonate through the ages. In this video, we'll uncover how Archimedes, the brilliant Greek mathematician and inventor, became one of the most influential figures in history. From his legendary Eureka moment to the machines of war that shaped ancient warfare, join us as we dive deep into Archimedes, how one man revolutionized science. If you're fascinated by the world of science and history, don't forget to subscribe to this channel. Your support truly means a lot and helps us continue to bring you incredible stories. Let's get started.
Chapter 1. The Genius of Archimedes. A boy was born in the old city of Syracuse on the island of Sicily. He would revolutionize the way people thought about the world forever. His name was Archimedes, and his genius changed the course of science forever, setting the groundwork for subjects like physics, engineering, and math. But he didn't start out as a ruler or conqueror. He started out as a curious boy who was really interested in the wonders of nature. Syracuse, a Greek colony, was one of the most important places for culture and ideas in the ancient world. There was a lot of trade, ideas, and influence from the great philosophers of the period in this city. Around 287 BCE, Archimedes was born here. We don't know much about his early beginnings, but we do know that he was born into a time where learning was very important. Archimedes was very interested in the world around him from a young age. He asked questions that most people didn't even think to ask. His curiosity would lead him to a life of discovering the rules of nature. Phidias was an astronomer and Archimedes' father. His family was probably well off, which gave Archimedes the chance to get a good education. He would next go to Alexandria, Egypt, which was the hub of learning in the ancient world at the time. At the great library of Alexandria, he would have come across the works of great mathematicians and philosophers who came before him. For example, Euclid changed the way we think about geometry, and Plato's ideas would have influenced Archimedes' thinking.
Archimedes learned the skills that would make him famous while he was in Alexandria. But Archimedes wasn't just a genius because he read a lot or learned from other people. He was a hands-on thinker. He liked to try new things, test ideas, and use math in real life. He didn't only want to learn about the abstract ideas of math and geometry. He wanted to use them to solve issues in the actual world. One of the most interesting things about Archimedes' talent was how he could connect pure theory with real-world inventions. Many of the great intellectuals of his time were happy with abstract notions and thought experiments. Archimedes, on the other hand, went further. His works were not merely theorems inscribed on paper. They were instruments, mechanisms, and innovations with practical applications.
He was a visionary who could see beyond what was in front of him, and knew that the key to figuring out the mysteries of the cosmos was not just thinking about them, but also doing something about them. Archimedes made important contributions to geometry, but his work in mechanics and engineering had the most profound effects on the world. It's impossible to picture how different the world would be if he hadn't come up with the ideas he did. Many of them are still used in modern engineering.
Archimedes was very interested in figuring out how objects moved, how forces worked together, and how the physical universe operated. He didn't merely make machines for the sake of making them, he made them to do something. Archimedes invented a lot of things, from simple instruments for lifting water to complicated war machines. He did this by using the basic ideas of physics and math that he had learned over many years. His love of nature helped him come up with important concepts in physics, such as his work on the principles of buoyancy, levers, and pulleys. He was the first to explain the basic ideas behind the lever, saying, "Give me a place to stand, and I will move the world with a lever." This straightforward statement shows how well Archimedes understood mechanical advantage, a theory that is being applied in cranes, scissors, and other tools today. But it was his discovery of the idea of buoyancy that really made him one of the greatest scientists of all time. The tale of how Archimedes discovered the principle is legendary. People say that Hero II, the king of Syracuse, commissioned a goldsmith to make a crown out of pure gold. But he thought the goldsmith might have used a cheaper metal instead of gold. They wanted Archimedes to find out if the crown was made completely of gold without breaking it. While he was taking a bath, he had an uncommon idea that helped him. When Archimedes got into the tub, he saw that the water level raised as he got in. This simple observation let him realize that the amount of water that was displaced might be utilized to find out how big an object is and how dense it is. He famously said, "Eureka!" or "I have found it," as he ran into the street, excited to tell everyone about what he had found.
The notion of buoyancy, which says that an item in a fluid feels an upward force equal to the weight of the fluid it displaces, became a key idea in fluid mechanics. This discovery not only helped the king, but it also set the stage for future work on fluids, densities, and how materials behave. Even today, Archimedes' principle is utilized to figure out how dense materials are and to build ships. But Archimedes was also a brilliant thinker in other areas. He was a bright inventor who was always seeking for ways to use what he knew about the world to tackle real issues. The Archimedean screw, which he made to lift water for irrigation, is one of his most famous inventions. There was a helical screw inside a cylinder that, when rotated, would move water from a lower level to a higher one. This simple yet successful invention changed the way people watered their plants in ancient Greece and Egypt, and it has been used for thousands of years. Archimedes also made important advances to military technology. When the Romans attacked Syracuse during the Second Punic Military, Archimedes built a number of military equipment to protect the city. The claw of Archimedes was a gigantic crane-like machine that could lift Roman ships out of the water and flip them over. It was one of the most famous. People also say that he invented a heat ray that used mirrors to focus sunlight and set enemy ships on fire. The tales of these inventions show how smart Archimedes was and how well he understood the forces of nature, both when they were helpful and when they were harmful. Even though he was famous, Archimedes was still a homely person who always put his job before getting credit for it.
He was more interested in finding new things than in getting rich or famous. People say he liked the stillness of his study, where he could think about the secrets of the cosmos without being disturbed. So, it's not surprising that he didn't die in war or in some other tragic event, but rather because the Romans took over Syracuse. When the Romans took the city, a Roman soldier killed Archimedes, even though he had been told to leave him alone. Legend has it that his last words were, "Don't bother my circles," which were the geometric patterns he was claimed to have been working on at the time. Archimedes' legacy would endure long after his demise. His findings became the basis for further advancements in math and science. His work would actually set the stage for the scientific revolution that would happen more than 1,000 years later. Galileo and Newton, among others, were inspired by Archimedes' ideas and built on his work to change the world as we know it today. In the following chapter, we'll talk about one of Archimedes' most famous discoveries, the Principle of Buoyancy. We'll also talk about how it revolutionized how we think about the physical world. Chapter 2: The Principle of Buoyancy. The narrative of Archimedes' most important discovery, the theory of buoyancy, is as well known as the man himself. It is a story that mixes the simple things that happen every day with the deep thoughts of a genius. The theory that would bear his name was not only a scientific accomplishment, it was also the essential to figuring out how things act in water. It also established the framework for a lot of fluid mechanics and current physics. But Archimedes didn't just happen to find this out. It was because he was incredibly curious, loved solving real-world problems, and had a bright mind that could see beyond the apparent. The story starts in the royal court of Syracuse, where King Hero II had a big dilemma. The king had hired a goldsmith to make a crown out of pure gold. But word had gotten out that the goldsmith might be using cheaper, less precious metals instead of some of the gold. Hero sought to find a means to tell if the crown was composed of pure gold without breaking it. It was easy to ask the question, but not so easy to answer. How could you assess the crown's purity without changing its shape? The tale goes that Archimedes had to find the answer. Even though the problem looked easy at first, it was very hard. Gold was heavy for its size because it was a dense metal. Other metals, like silver, were lighter. The problem was that they had to figure out this difference without melting down the crown or changing it in any manner. While Archimedes was thinking about the situation, he got an idea in the most unlikely place: a bath. Archimedes chose to take a break and relax in a bathtub one day. He noticed something simple but deep when he got into the water. The water level raised as he got in. It was a minor alteration, but it mattered. Archimedes figured out that the amount of water his body pushed out was directly connected to the size of his body. The more of his body that was under the water, the more water it pushed out. Archimedes made a connection between this observation and the problem at hand in a flash of insight. He knew that if the crown were composed of pure gold, it would push out a certain amount of water based on its size. But if the crown had less gold in it, it would displace more water, since a crown composed of a less dense material would have a bigger volume for the same weight. Archimedes had found his answer with this new information. He could tell if the crown was made of pure gold or if the jeweler had used a lesser metal by measuring how much water it displaced.
People say that Archimedes jumped out of his bath and ran through the streets of Syracuse, exclaiming, "Eureka! Eureka!" or "I have found it! I have found it!" A moment that would go down in history as one of the most renowned scientific discoveries of all time. As it is presently known, Archimedes' Principle of Buoyancy says that every item that is submerged in a fluid feels an upward force equal to the weight of the fluid that the object displaces. If you put something in water, it will push some of the water out of the way. The weight of the water that is pushed out of the way will push the object higher. This rule explains why some things float and others sink. If an object pushes away enough water to make it weigh the same as or more than the thing itself, it will float. It will sink if the object displaces less water than it weighs.
The beauty of Archimedes' principle is that it is so simple. It tells you why a big metal ship, like iron, can float on water, yet a little rock made of the same metal sinks. The ship is big and has a lot of space, so it moves a lot of water. This movement creates an upward buoyant force that is strong enough to balance out the weight of the ship. The rock, on the other hand, is considerably smaller and displaces much less water, so it can't make enough buoyant force to keep afloat. Archimedes' discovery wasn't just interesting to scientists. It changed many parts of life in important ways. In ancient Greece, as in many other places, knowing buoyancy was crucial for both practical reasons, such building ships and checking the purity of metals, and the future of science. The principle of Archimedes would set the framework for the study of hydrostatics and fluid dynamics, which are still important to current engineering, physics, and environmental science. Before Archimedes, people didn't know much about how water worked or how things moved in it. Many ancient philosophers thought that things floated or sank for mystical or unscientific reasons. Archimedes, on the other hand, used experiments and logical reasoning to solve the problem. He didn't believe in superstitions or abstract philosophy. Instead, he wanted a concrete explanation that could be tested and proven by how things acted in water.
His principle was so strong that it went beyond physics and into ordinary life. For example, it changed how ships are made. Shipbuilders understood that ships floated before Archimedes, but they didn't know why. Shipbuilders could now make ships that could not only float, but also carry bigger cargoes by changing their shape and size to move more water, thanks to Archimedes' concept. This knowledge helped ancient civilizations, including the Greeks and Romans, create ships that were better and better for trade, exploration, and battle. But Archimedes' discovery didn't just change the ancient world. It also paved the way for hundreds of years of scientific progress. Many years after Archimedes died, scientists and engineers used his concepts to come up with the equations of buoyancy and fluid dynamics, which are still taught in schools today. Modern shipbuilding, underwater exploration, and even the design of submarines all depend on the principles of buoyancy. It is interesting that Archimedes' concept was also very important in the construction of early scientific tools. The technique would be utilized to make hydrometers, which are tools that measure the specific gravity of liquids. These equipment proved very important in many industries, from chemistry to brewing, because they let people properly measure the density of liquids and figure out their purity or composition. Archimedes' research on fluid mechanics continued beyond the identification of buoyancy.
He would go on to come up with many additional rules about how fluids act, such as how to measure the volume of objects that aren't standard shapes. Archimedes figured out how to find the volume of things with strange shapes that couldn't be measured readily with standard methods by employing water displacement. Later engineers and mathematicians would need to be able to measure and calculate precisely. But Archimedes' discovery stayed mostly unknown for hundreds of years after he died, even though his premise was incredibly important. Most of his work was kept in the libraries of Alexandria, Egypt. It wasn't until subsequent centuries that people really understood and used his ideas in the larger scientific picture of the world. It wasn't until the Renaissance, more than 1,000 years after Archimedes died, that his ideas were completely rediscovered and used in the scientific revolution. The theory of buoyancy by Archimedes is a good example of how powerful observation and experimentation can be. It serves as a reminder that even the most important scientific discoveries can arise from moments of understanding that appear very simple. Archimedes didn't simply provide us an equation. He gave us a technique to understand the world around us that would change the direction of science for thousands of years. The next chapter will be on one of Archimedes' most useful and long-lasting inventions, the Archimedean Screw. It changed farming, engineering, and water management for hundreds of years. Chapter 3: Archimedean's Screw. The Archimedean screw is one of Archimedes' most important contributions to science and engineering. This equipment, which looks basic but is actually quite useful, has been used for thousands of years and is still a key part of current irrigation, engineering, and water management. But like many of Archimedes' other inventions, the screw was more than just a useful tool. It was a sign of how well he understood mechanics and how well he could turn ideas into real things. The Archimedean screw's tale doesn't start in a lab or workshop. It starts in the ancient world, when water was a valuable resource. Being able to move water to crops was important for farming, especially in places with dry temperatures. Some alternatives were rivers, canals, and wells, but these were often slow, unreliable, and not very effective. Archimedes knew that there had to be a better way to move water, and his answer was both beautiful and groundbreaking. The Archimedean screw is similar to a modern screw in that it has a helical surface wrapped around a cylindrical shaft. When you turn the screw, it picks up water at the bottom and moves it up the spiral, pushing the water higher. When the screw moves, it converts the liquid into a steady stream, making it easy to carry water from one area to another. This simple yet brilliant design uses basic mechanical principles, like the spiral shape's mechanical advantage and the screw's spinning, to move water against gravity. The Archimedean screw was a big step forward in terms of efficiency, and it also showed how much Archimedes knew about both geometry and practical engineering. Archimedes used the ideas of inclined planes and the screw to make a machine that could lift water without needing a lot of pulleys or people to do it. The screw worked by rotating, which made it considerably easier to use than other tools that needed more physical exertion or animal force. The Archimedean screw was first used to water fields, especially in Egypt, where it became a very useful tool for farmers. The screw made it easier and more reliable to move water from the Nile River and other bodies of water to dry areas than older ways. It was a gadget that transformed the way farmers worked in a big way, letting them grow crops in places that were too dry before. The Archimedean screw also made it possible to build better drainage systems in situations where there was too much water, like flooded farms or mines.
The Archimedean screw was useful in more than just farming. For instance, it was employed in mining to lift water from mines that had flooded. Ancient Greeks, Romans, and Egyptians utilized it to pump water out of deep wells and tunnels, which made mining easier and more productive. Because of this, the Archimedean screw was an important tool for the growth of many industries in the ancient world. The Archimedean screw was not only a great invention for its time, but it was also an idea that lasted for hundreds of years. It had an impact long after Archimedes died, as it became more advanced technology during the Renaissance and beyond. The screw mechanism, which has a spiral shape that goes on forever, inspired researchers and inventors in domains like fluid dynamics and mechanical engineering. The screw's ideas are still employed in pumps today, such as those used in factories, sewage systems, and even water delivery systems. The Archimedean screw may look simple, yet it had a huge effect on society. It was one of the first times that using math and physics to make things better for society in real ways. The Archimedean screw was a moment in history when human creativity and the rules of nature came together to make an instrument that would change the world in useful ways.
One of the things that makes the Archimedean screw so amazing is how simple it is. The design is still utilized in its original form in many parts of the world, especially in places where managing water is still very important. It is still widely utilized in hydroelectric power plants, sewage treatment plants, and irrigation systems. The Archimedean screw we have now is usually considerably bigger and stronger than the ones Archimedes made, but they all work on the same basic idea that he came up with almost 2,000 years ago. The Archimedean screw is not only useful, but it also shows how Archimedes thought about problems in a different way. He didn't only think about the world, he put his ideas into action. Archimedes built a tool that would help people for hundreds of years by learning about the rules of mechanics and using them to solve difficulties in the actual world. Even today, we still use his simple but effective design, which shows how brilliant he was. Archimedes' screw was a groundbreaking invention in the past that changed how people thought about machines and technology. But maybe just as important as the effect it had on the real world was how it showed how closely math, science, and real-world use are related. Archimedes was more than simply a mathematician or philosopher. He was also an innovator who knew that science's goal was not just to learn about the world, but also to make it better with that knowledge.
The Archimedean screw's legacy is not only in the machines it inspired or the industries it changed. It is also in the lasting example it established for future engineers, scientists, and inventors. Archimedes demonstrated that knowledge, ingenuity, and the application of scientific principles can resolve even the most urgent issues of the day. Even though Archimedes didn't have the same tools and technology we use today, he was able to construct devices that still help people in many important ways because he understood the basic rules of nature. In the following chapter, we'll talk about one of Archimedes' most famous but frequently misunderstood roles: How he helped with combat technology. Archimedes' inventions in defense technology, such as his well-known war machines and his work to protect Syracuse from the Romans, show how smart he was and how he could employ his scientific knowledge in many areas of life, even in combat. Chapter 4: Archimedes' Inventions and War Machines. Most people know Archimedes as a mathematician and inventor, but his talent went well beyond just studying and being curious about things. One of his most impressive and possibly less well-known accomplishments was his role in the Second Punic War, when he helped defend the city of Syracuse against Roman troops. During these chaotic times, Archimedes used his scientific understanding to make devices that would change the course of history. Not by using abstract calculations, but by making battle machines that were very useful and deadly. These inventions, which came from Archimedes' vast knowledge of physics, mechanics, and math, showed a side of him that was just as much about strategy and survival as it was about inventing things. The story of Archimedes' role in battle starts in 214 BCE, when the Romans were at their most powerful in the siege of Syracuse. The city was an important Greek stronghold on the eastern coast of Sicily. Rome was in the middle of the Punic Wars and wanted to get its hands on it because of its wealth, strategic location, and advanced technology. When Roman troops headed by General Marcellus started to attack Syracuse, the city's officials asked Archimedes for help. They understood that the great inventor was the only one who could help them protect their city from the Romans. The Romans laid siege to Syracuse for a long time, and it was very violent. The city was well protected, but the Roman army could still get through it. To protect the city's walls and harbors from attack, Archimedes utilized his creativity to create a succession of war machines. Each one showed how well he understood mechanics and how he could employ what he learned in school to solve real-world problems. The claw of Archimedes was one of Archimedes' most famous combat weapons. It was so powerful that it became a symbol of the inventor's genius. The claw, which was also called the ship shaker, was a huge crane-like contraption that was made to raise enemy ships out of the water. The claw worked by using a big, bendable arm with a grappling hook on the end. As a Roman ship got closer to the city defenses, Archimedes' invention would stretch out and grab the ship's hull, hoisting it into the air. Then, the crane would shake the ship so hard that it would break apart or capsize. Some stories say that the claw could lift ships so high that they would fall back into the water, breaking them with the force of the impact. The claw was an amazing bit of engineering, but it wasn't the only weapon Archimedes employed to change the tide of the siege in Syracuse's favor. People also said that Archimedes came up with the idea for a huge catapult, which was one of the earliest of its sort. The catapult was used to throw big rocks and other things at the Romans, which caused a lot of trouble and damage in their ranks. Some stories say that Archimedes even created a kind of ballista, a big siege weapon that could shoot bolts at a fast speed, making it even harder for the Romans to break through the city's walls. These machines showed how Archimedes could combine his knowledge of science with military strategy to make weapons that were not only effective, but also ahead of their time. The Archimedes death ray, which is also known as the Archimedes heat ray, is probably the most famous of all of Archimedes' inventions. Later versions made this device renowned. It was said to employ mirrors to focus the sun's beams on enemy ships, setting them on fire and destroying them.
There is a lot of disagreement over whether this heat ray really existed, but it's likely that Archimedes played around with the idea of using mirrors to focus sunlight, which was an early knowledge of optics and light. Some contemporary scholars have endeavored to reproduce the heat ray. However, its efficacy in combat continues to be a subject of uncertainty and conjecture. People commonly remember Archimedes' wartime legacy for the claw, the catapults, and the heat ray. But it's crucial to remember that Archimedes was a genius not only because he could make these machines, but also because he saw how they would be employed. Archimedes made things to help the people who were defending Syracuse win. His weapons weren't simply for killing, they were also for stopping the Romans and making their siege operations harder. Archimedes knew that the best way to defend yourself wasn't always with sheer force. It was to use science and technology to make things fair.
The siege of Syracuse would, however, end badly for the city in the end. The Romans were able to get through the walls of Syracuse, even though Archimedes made several great achievements. The city fell, and Archimedes was slain during the fall of the city. He had been so intent on his inventions and defenses that he didn't see it coming. People say that when a Roman soldier found Archimedes, he was so focused on drawing a math diagram that he didn't see the danger around him. The soldier killed Archimedes, even though General Marcellus had told him not to. He did it either out of anger or because he didn't understand. Archimedes' death marked the end of a time of great scientific and military creativity in Syracuse. Everyone who knew what he had done lamented his loss deeply. But even though he died, Archimedes' inventions nevertheless had an effect. People kept talking about and learning about his battle machines, especially the claw, even after the siege of Syracuse. They showed that Archimedes was more than just a mathematician or a thinker. He was a visionary who knew how to use what he knew in real life. His machines were very important in protecting Syracuse and giving the city more time to prepare for the huge Roman army. Archimedes' participation in combat illustrates the significant influence of science and technology in ancient military conflicts. In the past, overwhelming force and sheer numbers frequently ruled the globe. But Archimedes showed that intelligence and creativity could be just as formidable on the battlefield. His inventions, which were based on physics, geometry, and mechanics, changed the way people thought about siege warfare. They let a smaller, less advanced force fight back against one of the strongest forces in the world at the time.
People have always been fascinated by the claw, the catapults, and the heat ray. What makes Archimedes so special is that he could employ his scientific knowledge to solve real-world problems. He was more than just a mathematician who worked in the abstract. He was an engineer, an inventor, and a strategist who knew how to turn ideas into things that could change history. In the following chapter, we'll talk more about Archimedes' work in geometry, where he produced important discoveries that will affect the subject for hundreds of years. Archimedes' contributions to geometry show how smart he was. He did everything from figuring out areas and volumes to establishing the groundwork for integral calculus.
Chapter 5. Archimedes' Work in Geometry. Many people think of Archimedes as one of the greatest mathematicians of all time. His work in geometry is what has kept his name alive for so long.
He is probably best remembered for his useful inventions and work in mechanics. But Archimedes was an unparalleled master of form, shape, and proportion in pure mathematics. His study of geometric ideas would lead to new discoveries in math and have an impact on some of the most important advances in science, both ancient and modern. One of Archimedes' most important contributions to geometry was his ability to find the areas and volumes of shapes that weren't regular. Long before calculus was invented, Archimedes was already coming up with ideas that would later be recognized as the beginnings of integral calculus. He worked on finding formulas for the areas of circles, the volumes of spheres, and the surface areas of cylinders. These were issues that had stumped mathematicians for hundreds of years. He was able to use strict methods that showed the hidden structures of the natural world since he knew a lot about geometry. Archimedes' method of doing geometry was based on how carefully he paid attention to details and how he always used logical, step-by-step methods to find answers. Archimedes employed a rigorous and systematic way to solve problems, which was different from how many of his contemporaries did. They generally relied on basic visual observations or rules of thumb. He was known to use geometric constructs, experiments, and mathematical proofs to test his ideas and make sure they were correct.
One of Archimedes' most renowned works in geometry is how he figured out how to find the area of a circle. It had been a long time since mathematicians had been able to figure out how to find the area of a circle, but Archimedes came up with a simple yet effective approach to do it. He figured out that he could get close to a circle by drawing polygons inside and outside of it. This made it easy to figure out the regions of the polygons. Archimedes was able to gain a better and better idea of the size of the circle by adding more sides to these polygons. He demonstrated that the area of a circle is equal to pi multiplied by the square of the radius, a formula that is still very essential in arithmetic today. Along with his work on the area of a circle, Archimedes also helped people comprehend how spheres fit together. He showed that the volume of a sphere is 2/3 that of the cylinder that surrounds it, which is one of his most important findings. This answer was a beautiful way to solve a hard problem, and it would have a big impact on the growth of both geometry and physics. Archimedes utilized the same ideas he used to work on circles to figure out the volume and surface area of a sphere. His work on these forms would have an impact on mathematicians for hundreds of years. Archimedes' research on the surface area of a sphere was also very important. He demonstrated that the surface area of a sphere is 4 times the area of a circumscribed great circle. This formula would also become a key part of geometry, giving us a straightforward and accurate way to grasp the properties of three-dimensional objects. In fact, Archimedes was so sure he understood these geometric ideas that he famously asked for a sphere and a cylinder to be carved into his tombstone, along with the words, "Don't disturb my circles." This shows how close he felt to the shapes he had studied so much. One of Archimedes' most amazing accomplishments was figuring out how to find the volume of objects that don't have a regular shape. Archimedes figured the way to find the volume of objects that weren't basic geometric shapes before we had current techniques for measuring and analyzing things. He used water displacement to find the volume of an object. His method was based on the idea that the volume of an object could be found by how much water it displaced when it was submerged. This method would later be recognized as one of the oldest beginnings of integral calculus,
a groundbreaking mathematical methodology that would not be fully perfected until more than 1,500 years later. Archimedes studied the properties of spirals, parabolas, and hyperbolas in addition to spheres and volumes. These shapes would later become very important in calculus and analytical geometry. Archimedes' work on these curves was very important for the subsequent development of conic sections, which are very important ideas in both algebra and geometry. Archimedes studied these curves to learn how they acted in 2 and 3 dimensions. He made findings that would later help mathematicians like Newton and Leibniz when they created the rules of calculus.
Another important new idea in Archimedes' work on geometry was his approach of exhaustion. To use this method, you would draw simpler forms, such polygons or circles, within and outside of an item to get an idea of its area or volume. The more sides these designs had, the more exact the approximation got. This let Archimedes figure out areas and volumes with amazing accuracy. Even while the method wasn't as advanced as today's methods, it worked really well and laid the groundwork for later ways of integration and summation. One of the most impressive things about Archimedes' work in geometry was how well he combined theory and practice. His mathematical findings were not merely theoretical pursuits, they possessed practical implications. For instance, his work on the cylinder and sphere wasn't only about solving math problems, it was also about figuring out how the real world works. Archimedes was highly interested in the shapes and forms that controlled everything from the planets in the sky to the things on Earth. His study on the geometry of these shapes helped scientists learn more about the natural world and set the stage for later scientific progress in domains like astronomy and engineering. Archimedes' work in geometry was so important that it had an effect on the work of later mathematicians like Galileo, Kepler, and Newton. For example, Archimedes' ideas on motion and mechanics had a big effect on Galileo, who used them to come up with his own laws of motion. Kepler and Newton would also use Archimedes' work in geometry to come up with the laws of universal gravitation and planetary motion.
But Archimedes' work in geometry wasn't only about using math to explain the world around us. It was also about appreciating the beauty and elegance of math itself. Archimedes was very interested in the idea that arithmetic may help us understand the universe better. He thought that by looking at geometric shapes and how they worked, you could find the basic rules that govern everything. His careful work shows how much he believed in the beauty and harmony of math, and this philosophy still inspires scientists and mathematicians today. Next, we'll talk about Archimedes' life outside of his math work. We'll talk about his death and how his legacy will affect math, science, and engineering for many years to come. Chapter 6: The Archimedean Death and Legacy. Archimedes was a very smart and curious person. He made lasting contributions to science, math, and engineering, but his death, like so many other things in his life, was full with contradictions. He died in the height of his intellectual prowess, not from working too hard or trying to learn more, but amid the violent and terrible fall of his beloved city, Syracuse. Archimedes, who had spent his life building machines to protect his city and keep it safe, was finally killed by the very forces he had worked so hard to keep out. Archimedes died in 212 BCE, during the Second Punic War, when the Romans besieged Syracuse. The city, a proud Greek bastion, was one of the last independent areas that didn't want to become part of the Roman Empire. The Roman army moved forward, and Archimedes was asked on again to employ his wisdom to protect Syracuse. Even though the Romans were putting a lot of pressure on him throughout the siege, Archimedes kept working on his machines of war and using them to protect the city's fortifications.
Marcus Claudius Marcellus, the Roman general in charge of the siege, had known for a long time how smart Archimedes was. The Romans tried to take him alive because they knew how valuable his scientific talent was. People reported that Marcellus had ordered that Archimedes be spared because he thought the inventor was important to the Roman Empire. But, as fate would have it, a Roman soldier killed Archimedes, and he didn't even know who he was. It is said that Archimedes was so focused on a math problem that he didn't see the soldier coming. When the soldier addressed him, Archimedes is said to have said, "Do not disturb my circles," since he wanted to continue his job. At that moment, Archimedes' life was sadly cut short, and the world lost the brilliant mind that had once changed the tide of the siege. This famous narrative about Archimedes' last moments, whether it is completely genuine or has been changed throughout time, says a lot about the man himself. He was always dedicated to his academic pursuits and only cared about his work. It was ironic that he died, since his intellect had changed the way wars were fought, arithmetic was done, and engineering was done. It was also a sad reminder of how fragile human life is and how quickly intellectual progress may be lost in times of war and tragedy. But Archimedes' legacy would not be so easy to get rid of. He made a big difference in math and science, and even though he was gone, his ideas would go on and affect many generations of scientists and intellectuals. After he died, the Romans who had taken over Syracuse would still see how important his effort was. In reality, Archimedes' inventions were a big reason why the city didn't fall sooner. His war machines, especially the claw of Archimedes and his catapults, had caused a lot of damage to the Roman army, pushing them to come up with new ways to get through the city's defenses. After Syracuse fell, intellectuals and mathematicians who knew how smart Archimedes was saved his work. People meticulously recorded and passed along his publications on physics, geometry, and mechanics over the years, even though many of his other works were destroyed or forgotten during the turbulent times that followed. Archimedes' works were not recognized right away after he passed away, but later generations of researchers would find and accept them. It was until the Renaissance, around 1500 years after he died, that people really started to notice how much Archimedes had done. The rediscovery of his mathematical works, especially his essay on the sphere and cylinder, sparked the scientific revolution. Galileo Galilei and Johannes Kepler were two scientists who were inspired by Archimedes' work and used it as the basis for their own work in physics and astronomy. Galileo, in particular, embraced Archimedes' ideas about mechanics and used them to investigate motion. This set the stage for Isaac Newton to eventually explain the laws of motion. Newton used Archimedes' ideas to come up with his own new laws of motion and universal gravity. In this way, Archimedes' legacy went on in the scientific efforts of later generations, who built on his discoveries and improved his methods.
Archimedes had a big impact on research that lasted long after his time. His efforts will eventually help define the development of modern science.
Also, Archimedes' work in geometry, especially his groundbreaking work on finding areas and volumes, would have a lasting effect on the growth of calculus. Archimedes didn't know it at the time, but his methods of exhaustion and his way of obtaining the areas of irregular forms set the stage for Newton and Leibniz to later create integral calculus. Archimedes had effectively discovered the foundations of calculus long before the discipline was formalized, and his work would lay the groundwork for one of the most significant areas of arithmetic. Archimedes' discoveries and mechanical ideas would have an impact on generations of engineers and inventors, even in fields other than arithmetic. The Archimedean screw, for instance, is still used today for irrigation and managing water. The basic but effective design is still used in pumping systems all around the world, showing how useful Archimedes' discoveries are even now. Archimedes may not have gotten the praise he deserved in his own time, but his name would only get better over the years. Along with his work in math and science, Archimedes became a symbol of intellectual rigor and endurance. He was the perfect example of a scholar who sought knowledge for its own sake, no matter what perils and pressures were around him. Today, people honor Archimedes not only as a mathematician, but also as a symbol of human curiosity and creativity. Many books, documentaries, and academic studies have made his legacy live on. His name is still linked to new ideas and discoveries, and it continues to inspire scientists, engineers, and mathematicians all across the world. Institutions, schools, and scientific societies remember him and make sure that his work stays at the top of people's minds. The best way to honor Archimedes' legacy, though, could be to keep using his name. The Archimedean buoyancy force is still used today to assess how much buoyancy an object has. This shows how important his work is. His famous statement, "Eureka," has become a symbol of scientific discovery and the joy and exhilaration that come with figuring out the universe's secrets. In the end, Archimedes was more than just a person who lived and died at a certain time and place. He was a visionary who went beyond his time, and his work still helps us understand the world. He died, yet his legacy will go on forever. His capacity to use math and science to understand the physical world, his desire to learn about nature's most basic rules, and his will to come up with new ideas have all had a lasting impact on human history. In the following chapter, we'll talk about how Archimedes' works were found again and how his ideas changed the Renaissance and the scientific revolution, which led to the modern period of science and technology. Chapter 7. The Rediscovery of Archimedes' Works. Many people in ancient times knew how smart Archimedes was. Yet after he died, most of his work was forgotten or hidden. For almost 1,000 years, a lot of his important work, like his ideas on geometry, mechanics, and engineering, was lost in old books and libraries. But when the world changed in big ways throughout time, Archimedes' genius would be rediscovered. This would lead to a fresh interest in science and set the stage for the intellectual revolutions of the Renaissance and the scientific revolution. The rediscovery of Archimedes' works was not only an academic renaissance, it was a cultural and intellectual awakening that would influence the trajectory of human history. Scribes and intellectuals in the ancient world worked hard to keep Archimedes' works alive.
Many of his writings were copied and studied by following generations of mathematicians at the Library of Alexandria, Egypt, where they were kept. But as the Western Roman Empire fell in the 5th century CE, many of these works were lost or forgotten in the tumult and change that followed. As the Roman Empire fell apart, people stopped thinking about science and started thinking about how to stay alive and argue about religion. By the time the Middle Ages came around, Archimedes' works were hard to find, and his name was no longer linked to new ideas in science.
Even so, Archimedes' legacy didn't go away completely. His ideas lived on in the work of other ancient philosophers who had read his ideas and used them in their respective disciplines. For instance, Archimedes' work had a big effect on Ptolemy, a Greek-Egyptian mathematician and astronomer, and Nicomachus talked about him in his books on arithmetic. But for the most part, Archimedes' real impact on science didn't happen until the 12th and 13th centuries, when the ideas of the Islamic Golden Age started to make people interested in classical Greek knowledge again. During this time, intellectuals in the Islamic world, especially in cities like Baghdad and Cordoba, started to find and translate old Greek texts, including Archimedes' works. These scholars translated Archimedes' works into Arabic, keeping his ideas alive and making them known to more people. For hundreds of years, intellectuals in the Islamic world were the principal keepers of Greek science and math. It was through their translations that Archimedes' ideas started to spread to Europe again. Europe had changed a lot culturally by the time the Renaissance started in the 14th and 15th centuries. The rediscovery of classical works, particularly those from ancient Greece and Rome, served as a catalyst for the intellectual resurgence of the era. As scholars in Italy and other areas of Europe studied the works of ancient mathematicians, Archimedes' writings came back to light, and his ideas began to influence a new group of scientists and philosophers.
Girolamo Cardano, an Italian mathematician, was one of the most important people in bringing Archimedes back to life. He translated and analyzed many of Archimedes' works. Cardano's work helped make Archimedes' ideas on geometry and mechanics some of the most important in Renaissance science. The Renaissance's focus on observation and experimentation also helped people become more interested in Archimedes' work again. His comprehension of the physical realm, grounded in meticulous measurement and rational deduction, aligned with the emerging scientific ethos of the era. The first printed publication of Archimedes' full works came out in Florence in 1482. This was one of the most important steps in the process of rediscovering him. The Archimedes Codex was a complete collection of Archimedes' most important works, including his work on the sphere and cylinder, measuring areas, and the process of exhaustion. This was a huge event in the history of arithmetic, since it made Archimedes' work easier to find and read for students and intellectuals all around Europe. Over the next few hundred years, Archimedes' work would inspire some of the smartest people in history. His ways of doing geometry and mechanics laid the groundwork for eventual advances in science and math. For example, Galileo Galilei used a lot of Archimedes' ideas when he looked into motion and mechanics. Archimedes' discoveries regarding how force, mass, and motion are related had a direct effect on Galileo's work on the laws of motion and his experiments with falling bodies. Archimedes' impact was also vital in the evolution of calculus.
Archimedes lacked the instruments to codify calculus, although his exploration of the approach of exhaustion, approximating sizes and volumes by subdividing them into smaller, more manageable components, foreshadowed the essential principles of integral calculus. Isaac Newton and Gottfried Wilhelm Leibniz, who would independently create calculus in the 17th century, both acknowledged Archimedes as an intellectual forerunner to their work. Archimedes' methods had a big effect on Newton, who used them in his own work on motion and gravity. The rediscovery of Archimedes' work also changed engineering. Renaissance engineers examined and improved upon Archimedes' creations, such as the Archimedean screw. His knowledge of levers, pulleys, and rudimentary machines was the foundation of a lot of early mechanical engineering. Many of the inventions that Renaissance inventors, including Leonardo da Vinci, came up with were based on Archimedes' ideas.
The Archimedes palimpsest was found in a manuscript in a Christian monastery in Constantinople in 1906. This is probably one of the most well-known events in the recovery of Archimedes' works. The palimpsest was a parchment manuscript that had been erased and used again for Christian texts. It contains various works by Archimedes that were not known before, including some of his most breakthrough mathematical concepts. It took several years to figure out what the texts meant and put them back together. This gave us fresh information about Archimedes' work, especially how he solved issues in geometry and mechanics. The finding of the Archimedes palimpsest was a big deal in the history of math, since it showed even more of Archimedes' brilliance and solidified his place as one of the greatest mathematicians ever. Not only did the rediscovery of Archimedes' works promote the scientific renaissance, but it also laid the groundwork for modern physics and mathematics. Archimedes' theories and methods would have an effect on not only the scientists of the Renaissance, but also the great minds of the next few centuries. His writings would lay the groundwork for the scientific revolution, which would change how people understood the natural world in a big way. In the following chapter, we'll talk about how Archimedes' ideas and creations still have an effect on science and technology today. Archimedes' impact is still very strong today in sectors like engineering and space exploration. His legacy shows how strong intellectual curiosity can be and how important it is to always try to understand the secrets of the cosmos.
Chapter 8: Archimedes in Modern Science. Archimedes was a brilliant scientist and inventor whose ideas have lasted for hundreds of years. Even though he lived more than 2,000 years ago, the ideas he came up with still help us understand the universe. Archimedes' findings have had an impact on everything from the basic rules of physics to the most complex technical feats. His legacy is more than just a bunch of ideas. It's a thread that runs through the whole of modern science. The most important thing about Archimedes' work is that he knew a lot about mechanics. His work was the start of the study of classical mechanics, which people like Isaac Newton would later build on. The ideas of levers, pulleys, and buoyancy that Archimedes came up with are the basis for a lot of science. For example, Newton's third law of motion, which says that every action has an equal and opposite response, is similar to what Archimedes said about the forces that work in the natural world. If Archimedes hadn't done his groundbreaking work, Newton's principles, which form the basis of modern physics, could never have been thought of. Archimedes' comprehension of buoyancy, illustrated by his renowned principle, remains a foundational notion in fluid dynamics. According to the concept of buoyancy, an object that is submerged in a fluid feels an upward force that is equal to the weight of the fluid that the object displaces. This simple but important idea lets scientists and engineers figure out how things will act in fluids, including air, water, or other substances. Archimedes' original discoveries are the basis for the present study of fluid dynamics, which is very important in domains like oceanography and aviation. Archimedes' work on simple machines, especially the lever and pulley, is still very important in engineering. These simple mechanical advantage tools are what modern machines are built on. They are used in everything from cranes and hoists to complicated systems in factories and on construction sites. We use Archimedes' ideas to build not simply bridges and skyscrapers, but also complex spaceships and advanced robots. Many of the machines used to explore space, such as the Mars rovers and satellite systems, are based on the same mechanical ideas that Archimedes initially studied. The Archimedean screw is one of the most amazing things that Archimedes left behind. It is so basic and useful that it is still utilized in modern engineering. Originally intended to lift water for irrigation, the Archimedean screw is still used today in water treatment plants, hydroelectric power plants, and irrigation systems for farms. Modern versions of the screw have been made bigger so they can raise a lot of water. This shows that the screw is still useful for tackling some of the world's biggest engineering difficulties.
Archimedes' work also set the stage for the math we use today, in addition to the fields of mechanics and engineering. His approach of exhaustion, which let him get very close to finding areas and volumes, is thought to be the first step toward integral calculus. Long before Isaac Newton and Gottfried Wilhelm Leibniz made calculus a formal topic, Archimedes came up with ways to find the area under curves and the volume of irregular solids. Newton actually looked up to Archimedes and saw his work as a step toward his own discoveries. Archimedes' theories led directly to the invention of calculus, which would change the way we think about areas, volumes, and rates of change. The development of calculus in the 17th century may have been postponed or diverted entirely without Archimedes' seminal contributions. Even modern physics uses Archimedes' ideas. For example, his ideas are used in quantum mechanics, thermodynamics, and even in the study of the fabric of spacetime itself. Archimedes also made early contributions to astronomy that would inspire scientists for years to come. Archimedes was one of the first people to think about how planets move in a geometric way, even though science didn't know much about the universe back then. His research into the spherical shape of the Earth and the connections between the Earth, Moon, and Sun laid the groundwork for the heliocentric theories of the universe that Copernicus, Galileo, and Kepler would later create. People still use Archimedes' ideas in space exploration, especially when it comes to figuring out how gravity works and where things are going. The ideas of buoyancy and mechanical advantage that Archimedes came up with are very important for making spaceships, space stations, and rovers. To comprehend how spaceships move across the vacuum of space, utilizing gravitational slingshots and other means, you need to know about the forces that Archimedes studied. His early work on geometry and mechanics has even helped in building space habitats, where accurate measurements of weight, mass, and volume are very important. Archimedes' work has had an impact on the design of medical tools and machines. For instance, his ideas about how to quantify volume were used to make medical imaging technologies like MRI and CT scans, which use advanced fluid dynamics to make detailed pictures of the human body. The buoyancy principle helps us understand how liquids behave in the body, which helps us develop artificial organs and other devices that come into contact with bodily fluids. Even some recent devices that you wouldn't expect to use Archimedes' ideas do. Archimedes' method of approximation, which involved breaking down complicated shapes into smaller ones for calculation, was an early version of the methods employed in modern computational geometry. Software that makes everything from video games to 3D printed products employs similar algorithms to tackle geometric issues. This shows that Archimedes' methods are still very important to modern technology.
There seem to be a limitless number of ways to use Archimedes' theories, which shows that his work was much ahead of its time. But the real importance of Archimedes is not simply in how his findings are used today, but also in how his life and work continue to inspire scientists, engineers, mathematicians, and inventors of all ages. He didn't seek knowledge for glory or personal advantage. He did it because he couldn't stop wanting to learn about the world around him. Archimedes' legacy is one of intellectual curiosity, new ideas, and the strong confidence that math and science can change the world. People remember Archimedes in school today not merely as a historical character, but also as a symbol of what the human mind can do when it is focused on solving problems, discovering new things, and coming up with new ideas. People all across the world still learn from his work, which inspires future generations to explore the mysteries of math and science in the same way Archimedes did hundreds of years ago. Archimedes is still an important character in the history of human knowledge. His work has had a huge impact on the fields of science, technology, and mathematics that we know today. His concepts, ideas, and inventions continue to echo across the ages, reminding us that the pursuit of knowledge is not a transient undertaking, but a journey that stretches across decades and generations. Archimedes' name will always be linked to intelligence, curiosity, and the never-ending search for knowledge.